Okay, so this morning we will discuss first your homeworks. Okay, I purposely give you the crazy homework without showing the answer because I don't want you remember the answer and then only try to hit the 100% accuracy without knowing which question actually you answer. You don't know and then actually answer wrongly, right? So that's why some of you are PM me asking that which question you will keep answer wrongly, right? So means that yourself also not even know that some of the question you answer wrongly and then you keep repeating the same mistake. So that's my objective. So that's why I didn't show you, I didn't release answer to you, okay, when you answer the questions, right? But actually, the result is quite good, okay, but still lower than the expectation. As you can see, the overall accuracy only 79% for all the three uh, quizy exercise classwork 2.3, 2.4, and 2.5. Okay, regarding your essay questions, later I will take time to mark one by one and then I will return it to you. So this morning I'm not going to discuss the question yet, right? So see how's the time. If we got extra time, then maybe I will go through the question. Okay. So I know that maybe some of you are sharing the answer. Okay, you copy paste the answer to your friend, or your friend just only copy and paste. Okay, so from the text itself, the answer itself, the reason, I know that whether you are copy paste from your friends or not. Okay, if you think that there's a way that you are helping each other, right? So I really hope so that during the SPN later you can do so, right? So yeah, so now we look at the 2.3 first. 2.3. Okay, actually I expecting that the accuracy should be more than 85% because you are doing at home and then you have the chances to try, okay, and then you have the chances to check with the notes, okay, and so on. But right accuracy should be higher than 79%. Okay, so now we look at the result first of the questions. Okay, we go to from the bottom up. Okay. So this question, I noticed there's a two question repeated. Okay, sorry for the technical error. Okay, so even the two question repeated, but because your response is still consistent, you see that the accuracy or both question almost the same, no much difference. Okay, this question, so let me explain. Okay, this question, right? When another resistor is added to the parallel circuit, the total current. Okay, this question actually is passive SPM. Passive SPM. I know that the question is seem like not that clear because if the way how the resistor added to a parallel circuit, it doesn't mention. It doesn't mention. Okay, because we can assume that. Hold on, I can let me walk first. Okay. Alright. So according to the questions, uh, another resistor is connected to a parallel circuit. So to a parallel circuit, so now we can look at the basic parallel circuit first. Right. So basic parallel circuit. Okay, so one basic parallel circuit. Yeah, there is your parallel circuit. So the question said that another resistor connected to this parallel circuit. So now we look at this one. So this question, it can be have a two-way or the few way of the question of another resistor connected to the parallel circuit. Okay, so it can be connected like this. Another resistor connected. Another resistor connected. Right? Or another resistor connected. So there's another resistor connected to a parallel circuit. So they have the three, basically they have the three possibility. Right? There's the three possibility to add another resistor to a parallel circuit. If you really try to understand the questions. But I think it's a limitation of the sentence information given, right? The information given. So that's why it make the have a three possibility. But for the this question, actually, it doesn't want the students to think that so complicated, right? So because it mentioned that another resistor connected to a parallel circuit, so basically we try to understand it as another resistor connected parallelly to a parallel circuit, right? So it means that you still consider for the this condition. Is the one that you should consider. Okay, this one is the past year, exactly the past year question. Uh, so I agree that the question actually is not that, the sentence given information provided is not that perfect, right? So okay, anyway, when you look at the way of the system connected parallel to a parallel circuit, right? So it will make the overall effective out getting smaller. It will make the overall effective out getting smaller, right? So you can try to put some value, right, to do some simple calculation. Example, example, we try to assume that all the resistor have a 10 ohm. Let's say all the resistor has a 10 ohm. All is identical resistor, 10 ohm. So before that, we have the effective out of the circuit is 1 over 10 plus 1 over 10. So you have 1 over 5, right? And it means that our effective out is 5 ohm. If we have another connected parallelly, then we have a 1 over 10 plus 1 over 10 plus 1 over 10. So you have the 3 over 10. Means that your R will be 10 over 3. So it's about 3.33. So as you can see, the effective R getting smaller. The effective R getting smaller when you have another resistor connected to the circuit. Okay. But this calculation, it will be different where you look at another resistor connected to a parallel circuit. So connected series to this parallel circuit. So we have the 10 ohm here. Look at the pink colors here, 10 ohm, 10 ohm, and 10 ohm. So before that, original is the what? 5 ohm. Original is 5 ohm. If there's a parallel circuit that we have original 5 ohm. Okay. But with another new resistor connected to this parallel circuit. So now our effective R it will become 5 plus 10. So this effective R becomes 15 ohm, getting higher. Getting higher. Okay. So if you look at the bottom, another one. The bottom, another one. Okay, look at the green color here. 10 ohm, 10 ohm, and the 10 ohm. So original still the same. Original still the same is a 5 ohm. It's effective R. But because of another connected series with one of the parallel circuit resistor, so now our 1 over R, effective R of the circuit, 1 over R equal to 1 over 10 plus 1 over 20. So it becomes 3 over 20. So then the effective R of the circuit will become 20 over 3. Right. So it becomes 6.67. Okay, 6.67. So it means that it will be higher. It will be higher than the original. Right. So it means if you think the way of the resistor connected to one parallel circuit is the way of the connected by series, either series in the parallel itself or either series in the outside circuit. Right. So For the these three example, one of the conclusions to let you learn is no matter how the resistor connected, as long as it's connected in series, it will make the effective out higher. Either the series connected with the parallel like this, or either series connected inside the parallel itself. As long as it's a series circuit, connections of the resistor, it will make the effective out become higher than original. Alright, okay. But once you connected more in parallel, so it will be make the effective out getting lower. Once the effective out getting lower, then the effective colors will be higher. Effective color will be higher. Okay. So that's why. So the question asks about total colors, it will be goes up. Right. Okay. So there is a question looking for the answer. Okay. So the next one. Also now 55 accuracy. In the circuit shown above, what is the value of potential difference between point X and Y? Okay. So this one is also one of the past year question actually. It's because as I mentioned before, if you still remember, I told you in SPM, usually the basic question, because of the limitations of the syllabus itself, as I told before, normally all the calculation it will limit to three resistors only. Three resistors only. Right. So this is one of the example. Three resistors, so two connected in parallel, another one connected in series. Okay. Ayo. Okay, sorry, my son. Right. Okay. So but obviously that many of you really don't know how to do this calculation, so that's why you see the accuracy correct is only 55%. Okay, so around half of you, 45%, unable to get the correct answer. Uh, okay, sorry, this morning my son having a class, my wife also having a class, I myself also having a class with you. Right. Make sure the connection is good, so we all have to stay in the living hall, so we cannot go into the separate room. Right, so that's why. If you really have a lot of noise, please let me know. Okay, so now let's do together how to solve this question to find the V across XY. Okay, so if you still remember what I told you before, for this type of question, for those you can solve it easier way, yes, you can go ahead. For those you really cannot solve, please follow the steps that I'm going to show you now. Okay, look at the battery. Look at the battery. Here is your battery, right? Here's your battery, the power source. The battery itself, you see there's a ones region. Okay. Then at the same time, you have another separated region here. Okay, this separated region is the one that you have to solve it first so that you can simplify your circuit become like this. Original battery. There's the one resistor here. 4 ohm. This separated, there is a separated region here. This one. Right, this one. Okay, and then inside what we have? Inside we have the one resistor here. Inside we have the one resistor here, another one resistor here. So this is a two resistor inside, connected in parallel. So this is the one that you have to find. How much is let's say we have the RA here. So you have to get the 1 over RA. Find the RA. So it means that you have the 1 over 3 plus 1 over 6. Okay. So means what you have a 3 over 6. So your RA will equal to 2 and 2 ohm. So it means that you have the 2 ohm here. So now effective out of the circuit, will be 4 plus 2. It will equal to 6 ohm. Okay, and then provided the voltage is 6 volt. So V equal to IR. Then from here, you will get I is equal to 6 over 6. So it's 1 ampere. 1 ampere. Okay. So the reason that we get the current is to know how much is the voltage across the XY. Right. So where is the XY? XY is here. There is a X, here is a Y. So at the same time, if you want to find the easy way, here see 2 ohm here. So it means that the XY voltage, it will equal to the I out. So how much R across XY? It's a 2 ohm only. So 1 multiplied 2. Then you have the 2 volt. At the same time, you also can check how much is the voltage across the 4 ohm resistor here. So it will be 1 multiplied 4. So it's a 4 volt. That's why it still obeys the way of the potential difference divided by the series circuit, which is we learned before. We learned before V equal to V1 plus V2. So 4 plus 2 is still back to the 6 volt. Right? And here across XY here, look at that again, across XY, so we have the 2 volt, and the other side also 2 volt, because they are connected in parallel. In the parallel circuit, V equal to V1 equal to V2. So these 2 points, XY, is the same as these 2 points. So that's why the voltage across the 3 ohm, across the 6 ohm resistor are the same. It's a 2 volt. Because 3 and the 6 ohm resistor, they are connected in parallel. So connected in parallel, V equal to V1 equal to V2. But do not confuse the teacher. Why you say V equal to V1 equal to V2 is not the 6 volt, 6 volt, 6 volt. No, they are not the 6 volt. Because the 6 volt is overall. Overall, it's not across the same 2 points. Why is not across the same 2 points? Because you see, in between we have another resistor, 4 ohm resistor. So that's why it cannot be 6 volt. Right? So please, anyway, there's no 6 volt for the answer. So for those that alright, so you have a problem to understand this. Okay, so maybe you can make a screenshot here. So later on after the class, you try to come back here and revise back. Alright, so try to make the screenshot now. Okay, and then after that you press it into your Word if you use a laptop. Okay, so that later on you can revise back after the class. So the next one, so far so good, 65%. Right. In the circuit show, right? In the okay, in the circuit show above, what is the value of the current through the 4 ohm resistor? So you see, actually the same question that we solved just now. So the current, the calculation is actually exactly the same. To find this current, you have to get the effective resistance first. For the effective resistance, then you can use the V equal to IR, straight away you know how much is the current already. Alright, okay, so basically the calculation still same as just now. So what you have to do is you go through again the calculation that I show you. Alright, so this question. The total resistance of a parallel circuit is always what? Right. Always less than any of the individual resistance. Because as I mentioned from the first question that we discussed, as long as the resistor connected in parallel, the total resistance of the circuit, or we call it effective resistance of the circuit, it will become smaller. It will become smaller. Please take note. Right. It will become smaller. Once it becomes smaller, then for sure it was smaller than any individual resistance in the circuit itself. If the circuit is a parallel circuit, right? So you can try with the others value, you can try to do the calculation of the answer, right? Okay, so this was 72% accuracy. Alright, so the procedures are. What will happen if you took one of part of a series circuit? Okay, so for those answer wrongly, okay, maybe you miss our previous lesson. Previous lesson I told you already. Alright, so please remember. Okay, previous lesson actually there's another point that I haven't told you yet. So I think all of you need to take note of this point as well. Okay, before that, I just repeat whatever that we learned before this. Okay, I told you already. Actually, when the circuit showing there is a connections of the mental of the bulb inside, okay, each bulb actually is presenting one constant resistance of the bulb. Actually, it's presenting that is a resistor. There is a resistor. Alright, so just only that is showing there's a bulb. Right. So because of the design of the bulb, it doesn't change the physical design. It doesn't change the physical design. So the tungsten filament, the tungsten filament is the bulb itself. Okay, how long the length, how's the thickness of the tungsten filament, all is already fixed. It doesn't change the design. When it doesn't change the design of the bulb itself, so the resistance of the bulb is considered as a constant R unless the temperature increase. You have to go back to your Ohm's law. Under the Ohm's law, you not only learn the relationship between the V and I. Okay, you also learn the factor affect the resistance. Okay, so as long as the factor affect the resistance, it doesn't change. So the resistance of the devices, it will be the main constant value. So next time when the question show you there's a connections of the bulb, so the bulb presenting one constant R. Right? So please take note. Okay, other than that, another one question. Another one statement, usually the question will be give you the information. It will tell you the bulb light up with normal brightness. Okay, please take note for this. This not. Okay, normal brightness. When the question tell you there is a connections of the circuit, the bulb light up with the normal brightness, the meaning of this normal brightness is like this. When you tell you it's a normal, it means, let's say I give you bulb, okay, and connected with the one power supply. So I give you the power rating label of the bulb is example 24 watt, 36 watt. Okay. So that is the power rating of the bulb itself. Okay. To make sure this bulb has the normal brightness. To make sure this bulb has the normal brightness, I think this one is related to the essay question that I gave you in the classwork. It's based on what you already know. Okay. To make sure this bulb have the normal brightness, so we have to make sure that the potential difference across the bulb, it must be 24 watt. Right? It must be 24 watt. So with that, then you have the normal brightness. You have the normal brightness. Right? Because only with the 24 watt, you have the power of the bulb is 36 watt, which is every 1 second, okay, the energy consumed is 36 joule. 36 joule. Right? So this one is telling you that the energy is 36 joule per every 1 second. So with that, you have a normal brightness. If you have a higher than that or lower than that, okay, so the brightness is not the normal brightness. So it's quite often asked in SPM questions using this term normal brightness. So how are you going to ask? Example, so it's quite similar to like the essay question that you have in the classwork that I give you. Okay, so let's say I have the resistor here and I have the buck functions here. So let's say I have one battery is 1.5 watt. The battery is 1.5 watt. So I give you four battery. I give you four battery. Right? So and the bulb itself, I give you the power rating of the bulb. Okay, let's say it's 5 watt, 12 watt. Okay. So how are you going to connect the battery into this circuit to ensure that the bulb is have the normal brightness in the circuit? Right. So this one is actually similar to okay, the essay question that I give you as a classwork. Okay, for sure, you must at least provide 5 watt toward the bulb in the circuit. Okay. But to get the 5 watt, you need to connect the series, all the battery in series. The four. Because you connect three in series, you only have, when you connected three, you only have 4.5 watt. It doesn't enough for 5 watt. So when you connected all the four together, now you have the 6 watt, right? You have the 6 watt. That's why you need another R here. As a, we call it as a potential divider. Okay, this R we call it as a potential divider. Please take note. Okay, actually this term, the R function in the circuit like this, we call it potential divider. This term actually we only use it in chapter 3 later. Okay, we only learn it. No, sorry, we only learn this term in the chapter 4 later. Chapter 4. Okay, where we learn about the automatic switch circuit with the use of the transistor. Alright, so but for now you learn the terms first. Okay, we call it potential divider. Because without the this R, our V it doesn't divide to the V1 and V2. But because of this R connected in series like this, then we divided our V into the V1 and V2. So that's why the R that we connected, we call it potential divider. It divided our V into the V1 and V2. So with the R that we have here, then finally we can have a 5 watt across the bar. Means here it will be take another 1 watt. You take 1 watt across this R. So I can make this one as a question now for you to practice. Alright. So find me how much is the resistance R that you must connect in this circuit, so that you can have the normal brightness for the bar, okay, of the circuit. How much is the R that you must connect into the circuit? Do the calculations now. Okay, copy down this question. I need you to find me how much is the R that must connect into the circuit to ensure our bulb have a normal brightness. Okay, so there's a one question from the question. Okay, if we can choose between a voltage that is just enough, and one of that is higher, which one to choose for normal brightness? Okay, so that's why I think I answered your questions already just now. Okay, with these questions. Right. So means that if you connected, all become higher, but if you not connected all, then it become lower. Then what the option is you need the potential divider to make sure that the voltage across the bulb is enough for the bulb have the normal brightness. That's the way that we make the decision. So you can make the corrections on your essay question. You can go back to your classwork to unsubmit. Okay, and then after you make a correction, then you submit again, resubmit. But the problem is you do so, then your record will be let submit because it's already over the due date. Okay, I think that you can't be bothered about that. Okay, it's just a record only now. As long as you do the corrections before I answer, if you want to do so. Right, so you can unsubmit to make the correction. Right, so anyone find out how much R that you did already? Right, so to solve this question, you have to recall back what I told you before, which is the bulb in the circuit actually presenting a constant R. So how to find the constant R of the bulb? Use the power rating they given. Last week, our last lessons, I told you already. Okay, how to find the R. Actually, just only apply the formula. So this morning attendance is still not so good, Right, so we have 2.5, 2.0. Is it the value give is the resistance of the bulb or the resistance out in the circuit? Right. Straight away tell me the resistance out of the circuit. Not the resistance of the buck. That is a process that you have to find before you get the password. Password. Because I have a look. I'm studying the machine in my handphone. Sorry for that. Okay. So to find the R in the circuit, you have to find the resistance of the buck first. Then only can get the final R of the circuit that you have to connect. There's a few ways actually. There's a few ways. Depends on how you solve. Another one way is you should find the currents. Because the normal minus, okay, it have to depends on the current. Okay, so this one later you take notes again. I will tell you another one importance that I forgotten to tell you. I see we discussed the question, so that's why I let you know. So recently I received a message from the Renta mother. The message sound like this. Linda has been trying to join the Google Classroom, but our internet is a bit slow. And we keep lagging, so she will join as soon as possible. Sorry for the inconvenience. Is there anyone of you have the lagging problem if even you are using the handphones or what? Don't know. So actually I am very, very disappointed with the learning attitude. If you really like to want to learn, no matter how you still will try. Okay, so since most of you is already have the answer 2.080. Okay, so we see as I mentioned before, you can try to find the resistance of the buck first. Right? Resistance of the buck here. Right? How to find it? With the formula V squared over P. V squared over P. So for those that you're confusing, teacher, how to get this formula? We have in the exam, we will give you P equal to VI. And we know that V equal to IR. Right? So you can substitute I as what? I as a V over R. V over R into the P equal to VI. So we have the V squared over R. Then the R will be equal to V squared over P. So from here, to get the normal minus, so it must be the 25, 5 V squared, so over 12. Then you will get the resistance of the buck that you have. So let me use pass me calculator. Where's our calculator? Other paper got on. So yeah, I find my calculator. Alright, 2.0 at 2.0 at that is the resistance of the buck. 2.0 at 3. Okay, 2.0 at 3. So now you know the resistance already. Alright, okay, 2.0 at 3. So what is the current here? 2.0 at 3. Okay, how much the current? The current is P equal to VI. The current is P equal to VI. Then how much the current? So the current will be equal to P over V. So it will be 12 over 5. That is your current, 12 over 5. So 12 over 5, you will get 2.4. Right? 2.4 ampere. 2.4 ampere. Okay, 2.4 ampere. So basically, to find the resistance of the buck is not really useful here. Right? 2.4 ampere. So now you know that the color is 2.4 ampere. Color is 2.4 ampere. Then the 1 volt is equal to 2.4 multiplied R. So that's why the R is 1 over 2.4. Okay, 1 over 2.4. Okay, so the resistance actually is at 0.42. 0.41742 or 0.42. Okay. So if you have a higher voltage, if you have a higher voltage than the normal enough voltage, okay, if you have higher than that, then your brightness will be greater than normal brightness. You will have the normal, but it will greater than normal brightness. Yes. It's okay now. Sorry for the noise just now. Okay, come back to these questions. Right. So remember, when the question told you normal brightness, the voltage across the device or the bulb itself normal brightness, it must be the 5 watt as a power rating voltage. It cannot be more than that or less than that. It cannot be more than that or less than that. If you have a less than that, then your brightness will be dimmer. Right? So the brightness of the bulb will be dimmer. First one. If you're higher than that, then the brightness will be greater than normal brightness because the color delivered will be higher. So this happens sometimes that when you watch a movie, okay, when you suddenly have the higher electric currents go to the table, so the brightness of the bulb suddenly will become brighter than normal. Then if you keep increase the current supply, so it will make the bulb as burst. It will make the bulb burst because it will be overloaded. Overloaded, so it will be burst because there's too much energy delivered. Too much energy delivered. Okay, so that's why to have the normal brightness or let the device function normally, we should supply the voltage according to the power rating suggested. It cannot be higher or lower than that. Slightly higher is still fine because we still have the fuse inside to control. Okay, but to get the normal working perfectly, so you should follow the power rating. All right. Okay. So this question that we know, right? So I repeat again, sir. For these questions, right, so since that we provided 6 watt, we provided 6 watt in the circuit, we have a 6 watt here. But the problem is the bulb provided power rating is a 5 watt and the 12 is it? 5 watt and the 12 watt power, 12 watt power. Alright. And if you connected like this only, as you see in the screen, if you connected like this only, so it means that the voltage delivered toward the bulb actually is a 6 watt. Right? Because there is the only one device in our circuit. So the voltage delivered to across the bulb will be 6 watt. 6 watt is higher than 5 watt. Means the bulb it doesn't light up with the normal brightness. So it cannot be like this only. So we need another potential divider. So we connected another resistor R here. Then with that, so we can divide our voltage into two different values. So it will be the here will be the V1 and here will be the V2 because there is a series circuit connection. We only know that the V2 it must equal to the 5 watt because the condition of the question is the bulb have to light up with the normal brightness. So normal brightness V2 must be the 5 watt. That means automatically we know that V1 is the 1 watt. Okay. So to have this 5 watt with the power rating here, then we know that the P equal to VI. The P equal to VI. So from here we able to know the I is equal to P over V. P over V, so it will be the okay, 12 over 5. So we get 2.4 ampere. So there's a current 2.4 ampere. Current 2.4 ampere. Means the current flow in the circuit, because it's a series circuit, so the current flow is a 2.4 ampere. So here V1, V1 is equal to the R. So V1 you know there's a 1 watt. The current flow through it is a 2.4 ampere. And multiply the R of the resistor. So from here, we're able to know the resistance of the R is 1 over 2.4. That's why with the calculation, you get the answer is 0.417 ohm. Right, 0.417 ohm. So that's why we know the resistance. R have to connected. Okay, series with the bulb to ensure the bulb connected no light out with the normal minus. The resistance connected series with the connections of the bulb is 0.417 ohm. Right? Okay. Can you explain the first two circuit for the essay question again? Is regarding the normal minus. Right. Okay. So as I mentioned, the normal minus, right? Okay. Example, this one is a similar to the essay question that I gave you. Because the power rating of the bulb given, like example, I can't remember what is the value of the essay question given. Right, it's a 5 watt. It's a 5 watt. But you're provided by the question, battery is only 4 example. Each battery 1.5 ohm. If you connect it in 3 in series, you only can get 4.5 watt. It's still not enough for the bulb light up with the normal minus. And to make sure they have the normal minus, you must apply 5 watt across the bulb. But if you put all the 4 battery together, total you have a 6 watt. It will be more than normal minus require. Right? So that's why you need to connect the series, another R with all the bulb that you have. Right? So I hope that with this you able to understand, okay, how to make your decision.